In this example, we are going to use the nodal analysis to find V naught in the network. V naught is over here. And this problem is different from the previous ones because we have a dependent source. So we have learned that for a problem like this, we will treat the dependent source as the independent ones from the beginning. Then we write the nodal equations, and towards the end we'll add an additional equation for the control variables. And in this case, this current depends on V naught, so we are going to write the equation about the V naught in terms of the nodal voltage that we are going to define. Let's work on this problem. So step 1, we're going to select the reference node. So in this example, we know that many branches are connected to this node, so we are going to select this node as reference node. Then we're going to define all the nodal voltages. So we want to make use of the variable that's already defined in the circuit. So if we use this as V naught, and by looking at these two resistors that connected in series, and if this node has a nodal voltage of V naught, it implies this node have a nodal voltage of 2 V naught. This is a voltage divider circuit. When you have two resistors in series. Now we can move on to find the nodal voltage of this node, that is 2 V naught minus 12. So what's nice about this problem is that by using one variable defined, which is V naught, and we labeled all the nodal voltages. So everything that is related to V naught, because we make full use of the relationships. So the second step is to write the nodal equations. So in this problem, since there is only one unknown, so we're going to only need to write one nodal equation. At the same time, we know that we cannot write a nodal equation as this node and this node because they are connected to this voltage source. We know that we need to write a nodal equation at this reference node. There are 4 branches that are connected to this reference node. We'll write all current goes into the reference node that adds up to 0. The current in this branch, because it's leaving, so we have a negative V naught over 2. And the current in this branch, that is 2 V naught minus 12 divided by 1. The current in this branch, that is 2 V naught divided by 1. The current in this branch, that is V naught divided by 1. So this will add up to 0. So step 3 becomes to solve this equation. By solving the equation, we can find V naught is equal to 8 over 3 volts.